Hey, Pre-AP kids, welcome to lesson one for dimensional analysis. At this point, you guys have finished the first exam for Pre-AP Chem. Congratulations. I don't know if I've already graded them and put them in as I'm doing this ahead of time, but your grades will probably show up in the grade book before you actually see your test. That's very unusual for me. Normally, I would let you see your exam before it goes into the grade book. That way you can prepare yourself and your parents for what's about to happen. But under the circumstances, because the tests have to come to me, I have to grade them, then I have to find a way to get them back and COVID. So it's probably not going to happen here. So anyway, you can look online, should be by the end of the first day. They should be complete in the grade book, maybe sooner. I don't know. I'm pretty fast about the exams. Been slacking a little bit on your labs. I know, I apologize, but doing the best I can. Okay, so lesson one. I'm going to share my screen and let you guys look, but and we're going to go through several problems today in this. I don't know if this is going to take the full class period or not. I hope not, as I'll go kind of fast, but I'll pause, and if there's a part in here where you need some more time, let us know, or put pause on the video and go and take care of your business. What we're going to move into is just straight up math. I'm going to show you a process called dimensional analysis, but it's basically converting from one unit of measure to another unit of measure. And you do it in your head all the time. You just don't realize you do it. But you've got to take from your brain and put it down on the paper, because when we start talking about things like atoms, molecules, masses of certain, moles of elements and such, you're not going to be able to do it in your head anymore. And so some of you will want to do some strange things, and I'm going to try to convince you not to do that. But the bottom line is, if you will do it the way I show you how to do it, chemistry will be much easier for you. So do what I tell you to do. Even though you think you've got a better way, this is the way. So let me share my screen here, and I will share my screen, and we'll get started. So there we go. So problem solving in chemistry is what this is really about. And there's some simple steps to, and I'll go over them with you, to actually solving word problems, because these are all going to be, for the most part, word-based problems. Some of the first ones we do will just be simple conversions to get you started. But after that, you'll have to read in the problem what they want you to solve for and what you're being given. And I'm not really very good at, you know what, I'm not going to say that. I'm going to go ahead and I'm just going to teach you, and you can be the judge of how good I am at it. Okay. But what we need to do are our objectives for this lesson, this first one, and we're just going to do some simple ones today, is to understand the use of the conversion factors using something called dimensional analysis, or also called factor label. But dimensional analysis, and then we're going to do a lot of some easy dimensional analysis conversions. So some steps for solving word problems. The first thing you need to do is figure out what you're given and what your want is, or what your known and your unknowns are. So what you're looking for is what they want you to solve for, and what they're giving you at the beginning that you're going to use to get to that end result. Basically, you need to plan a solution. You need to plan kind of how you're going to get there. The unit should guide you. I mean, you're going to use your units to find out the other unit you need. So it'll make sense once we do some of these. Then you perform the calculations, and then you need to look and see if it makes sense. Now, a lot of these, you're not going to know if it makes sense. If the unit is, 5,200,000 seconds, you're not going to know if that makes sense or not. But make sure that you've got the right number of significant figures and that you have the right units in your answer. That is certainly true. So what dimensional analysis is it's just a way to get down on paper your problem solving. And so you're trying to manipulate the units so that you can change from one unit of measure to another. So this is done with what are called conversion factors. And I've got a couple of conversion factors listed down here. $1 is 100 pennies. $1 is always 100 pennies. 100 pennies is always $1. There's no significant figures there. It's an exact number. And so it has unlimited significant figures. You're not concerned with how accurate that is. That's just a fact. So if you wanted to know how many pennies you have in a certain number of dollars, you could, divide the number of dollars. Multiply the number of dollars by the number of pennies, or by 100 pennies. but you have to be able to write that down on the paper. You have to be able to show how you're going to do that unit conversion. The same thing is true with the 1 foot and 12 inches. There are some other ones down there. But what you can do with these, which is kind of cool, is you can flip them. So these two are reciprocals of one another. So if you're trying to end up with pennies, excuse me, you would use the one on the bottom. If you were trying to end up with the number of dollars, you would end up with one on top. And so let's do a couple of these. One thing I want to ask you a question and see if you can do it in your head, which I'm certain you can. But let's say you have 36 inches. If you're given 36 inches, how many feet is that? You probably should, said out loud or in your head, you said, oh, that's 3 feet. Of course, that's 3 feet. You know that, or at least you Americans in here know that. We seem to do everything in inches and feet, which is ridiculous, but whatever. You just divided the 36 inches by 12 inches because 12 inches are in 1 foot, and that gave you 3 feet. I am aware that you can do this in your head, but you have to be able to show us how to do it. So when you're no longer able to do it in your head, you have that ability. What we did essentially is we took our 36 inches and we converted from 12 inches to feet, knowing that 12 inches is 1 foot. And what you do is you're going to multiply across the top, multiply across the bottom, and divide those two. Or if you like, 36 times 1 divided by 12 is in fact 3 feet. What we've done is we've just shown the work that you did in your head. Yes, I know you divided by 12 inches because 12 inches are in a foot, but that 12 inches in a foot is that conversion factor I'm circling right there that you need to understand. A lot of times the conversion factors are going to be given to you within the problem, and we'll do some of those today, more tomorrow, but some today. And so we'll convert them from, one unit of measure to the other. Regardless of whether you know it in your head, you have to be able to put it on the paper. So here we just have a simple thing. We're changing from a certain number of meters to millimeters. So when you set these up, and some of you are going to want, oh, I want to use little time symbols, or I want to do this and that. Please do it my way. When we start adding compounds and molecules and moles and masses all in the same problem, and it's 9 steps long, you're not going to be able to do it with little fractions and ratio stuff. You need to do it this way. There will be a few of you, maybe 5 in all of my classes put together, that will absolutely not do this. And when it comes time to do it later, you will be completely lost because you didn't do it this way. Do it this way. Okay, enough. So what I want to do, and an excellent way to do this is where I'm really not very good, is you really should list your given, and you should list the thing that you want, or your knowns and your unknowns. Your unknowns, what you're trying to solve for, and your knowns are your givens, what they're telling you. What they're giving us in this case is 52.5 meters. That's usually going to be your starting point. Sometimes the givens are going to be conversion factors you use in the middle of the problem, but in this particular case, they're telling us our given, which is our 52.5, and what we want is to change that to millimeters. Now you're saying, Todd, it's just right there in the example. Why do I need to write this? Not all the problems are going to be this simple. This is problem number 1. So get in the habit now of writing your givens and your wants. Now, I have worked with teachers in the past that graded you on whether or not you write your givens and your wants. I'm not going to do that. You can do it however you like. But if you're not showing them, that's going to be the first place you're going to make mistakes. So anyway, my given is 52.5. So what I want you guys to do is take the 52.5, write the unit meter, and then I want you to draw a line. I want you to draw a line like that. The next thing I want you to do is to draw another line, but it goes down like this. Now, you're doing unit conversions. So I would actually recommend you do this entirely in units before you do any of the numbers. Now, what we're trying to do is to change meters. So I will write meters diagonally below it, and I'm changing meters to millimeters. That's it. This is pretty much the entire problem. I do need numbers here, of course. And hopefully from the last unit, you were asked to memorize what that conversion is, but there are 1,000 millimeters in 1 meter. Something that helps me a lot when I'm doing this is to put a 1 in the one that's bigger. Meters are going to be bigger than millimeters. So put a 1 there. And then the one that's smaller, I'll have a lot more of those. That will get the 1,000. There's a lot of people that will accidentally write 1,000 meters in 1 millimeter. And that's silly. How can you have 1,000 meter sticks in a single tiny millimeter? You can't. So if you'll put a 1 in the one that is larger, it'll keep you from kind of doing that. Anyway, what you're going to do is multiply these two out. what you end up getting to three significant figures is 5.25 times 10 to the fourth millimeters as your answer. Now, you could have just written this in regular notation, but it's a good idea for us to go ahead and get it in scientific notation because that's where we need to be. All right, there's the same thing, but look, it's so pretty. So much better than Talt's handwriting. Let's go to another one. This one will require probably more than one conversion. I don't recommend changing things from kilometers to centimeters just straight away. I would always change your unit to its base unit and then out of the base unit to the other unit. Don't try to go kilometers to centimeters and say, oh, there's 100,000 centimeters in a kilometer. Don't do that to yourself. Instead, change kilometers to meters and then change meters to centimeters. It's better. So once again, I would list my given and I would list my want. My given here is 73.2 kilometers. And my want, what I want to change this to is centimeters. So let's see if I can get more comfortable writing this down. So what I have here is 73.2 kilometers. I'm drawing a line. I'm drawing another line. I need to first convert from kilometers to something else. So I'm going to write kilometers down here in the bottom. I know I can convert kilometers to meters. So I put meter on top. And then I'm going to need another conversion to get to centimeters. What I would do here is put meter on the bottom and centimeter on the top. And then I can put in my numbers. The unit that is larger in the kilometer meter conversion is the kilometer. The unit that is larger in the meter centimeter conversion is the meter. There are 1,000 meters in a kilometer. There are 100 centimeters in a meter. And so what I have done here is just set up the problem. You multiply all the way across the top, you multiply all the way across the bottom. In this case, it's just 1, and you'll get your answer. Now look at your units. I know you're writing furiously, but look up here at what I'm doing. Kilometers will cancel with kilometers because once I multiply this all out, they'll be on top of one another, canceling out. Just like, 2 over 2 would cancel out, the kilometers and kilometers will cancel out. So will the meters. What I'm left with is centimeters. Oftentimes, if it's just a single conversion like this, the unit you have at the end, at the top, will be what you're trying to get. And in this case, our want, what our get is that centimeters. So if I multiply this all out, I end up getting 7.32 times 10 to the 6th centimeters. That's dimensional analysis. I'm going to show you a bunch of other ones, and we're going to convert time, and we're going to do some density. But essentially, this is all we are doing from now until the exam. We're just practicing this. There's only 2 days of lesson, in fact, because it's so little. But you just have to practice, 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 practice. So there's the pretty, look at that, much better font. So here, we got how many seconds in 2.5 years? So I'm going to list my given and my want, and then I'm going to ask that you guys push pause and go ahead and give this one a shot, and then come back and I'll work it out for you. But my given is that I have 2.5 years, and my want in this case is the unit to change to seconds. So what I want to know is how many seconds are in 2.5 years. So hit pause, give it a shot, and then come back and I'll work it out. Okay, so I'm working it out. So 2.5 seconds, and I'm going to draw a line, but I'm anticipating that my line is going to need to be a little longer this time because I don't know a conversion factor that goes from seconds to years. Now, some of you may, know a Broadway musical which talks about the number of seconds in a year. Don't do that to yourself. Just learn how to do the process here. Okay, so I need to change to years. So I need a plan of how, sorry, look what I did. I can't believe I did that. Look at that. What a moron. Okay, 2.5 years, my bad. We need to change from years to seconds. So I need something that I can get. I got to kind of work backwards to figure out where to go. So I can change seconds, or I can get to seconds from minutes. I can get to minutes from hours. I don't know how many hours are in a year, but I can do hours in a day. Do you know how many days are in a year? Yeah. So there's our plan. So what I'm going to do is I'm going to change from years to days. There are they're not 24 days in a year. There's 365. This is not going to go well. 365 days in 1 year. I could change days, I'm pretty sure, to hours. And if I keep going with my units here, I could change hours to minutes, and I could change minutes to finally seconds, and that will get me there. I'll go ahead and put my numbers in now. So the larger of the two with days and hours, there's 1 day and 24 hours. No doubt some of you will say there are 24 days in an hour. That's not correct. 1 hour is 60 minutes. 1 minute is 60 seconds. And I've set my entire problem up. You multiply all the way across the top, you multiply all the way across the bottom, and you divide the two. In this case, once again, we're making the unit smaller, so all the numbers in the bottom are 1, so that makes this denominator really easy. When I do this math, I end up with 78,840,000 seconds. Okay, no, we're not leaving it that way. The 365 in a year, that's exact. 24 in a day is an exact number. There's 24 hours in a day. There's 60 seconds in an hour and 60 seconds. So where I'm looking at my sig figs here is going to be at the very beginning, the estimation, the 2.5 years or 2.5 years. So I need to round this number to 2 significant figures. So that would be 7.8. And then I need, times 10 to however many power that is. And I believe that is 7. Is it? 1, 2, 3, 4, 5, 6. Yeah. 10 to the 7 seconds. So yeah, that very last, you get your answer, have it in your calculator, look at it and say, okay, I need to round this to sig figs always. And sometimes your conversion factors have significant figure things in there. We'll do a couple of those, but generally speaking, it's kind of the first number. All right. Oh, look, they're super pretty. And they started with 2.5 years. All right. So here's one that's a little bit different. It says, and let's list our given once when we do this, but an average human heart beats 60 times per minute. That 60 times per minute means it's 60 times in 1 minute, right? If you live to be 82 years old, how many times will your heart beat? So my given here is they're telling me I'm 82 years old. And what I want to convert that 82 years to is to the number of beats. And one of the other things that they're giving me here is actually a conversion factor. They're saying that there are 60 dot beats, or the times it beats, in 1 minute. So that right there is a conversion factor, and it can be flipped. It could be 1 minute equals 60 beats on bottom, or it could be 60 beats on top equals 1 minute on bottom. We just kind of figure out what we need. But using that conversion factor at the very end of this problem will give us beats in the numerator. So that's probably what I need to do, is change from years to minutes, and then I can change it to beats using the conversion factor they gave me. So let's go ahead and start. 82 years old, fine. And this one will require a line. I need to change from years to minutes, and I can't go from years straight to minutes. So I'm going to do the years to days like we did in the previous one. I am going to change from days to hours, and I will change from hours to minutes. And then I can use that conversion factor changing from minutes to beats. And that conversion factor used 60 decimal, means exactly 60 to 2 sig figs in 1 minute. And so going back, once again, the year is larger, so I'm gonna put a 1 here. There are 365 days in a year. 1 days is 24 hours. 1 hour, of course, is 60 minutes. And then I'll get my number of beats. You multiply all the way across the top in your calculator, divide by 1, or just leave it alone, and that will give you your answer. So for this one, the number of beats is 2585952,000 beats. Good night. That's crazy. If I look at what I'm given in here, I believe this is an estimation, because I've got a decimal point there, and the 82 years, both of which are 2 significant figures. So I'm going to round this to 2.6 times 10 to the 3, 6, 9. So that's going to be 2.6 times 10 to the 9 beats, which is a lot. Yeah, in 82 years, that kind of makes sense. Okay. So that's about the difficulty level of the stuff I wanted to show you. There are some other ones here that are a little bit, they can be a little bit longer or could give you some other conversion factors. You got to kind of figure out how to get there. But some of these are a little puzzle-esque. You may have, it's like figuring out a puzzle to get them to work. But these to start with are a little bit easier. This one is a little strange. A clock gains 0.25 seconds per minute. How many seconds will it gain in exactly 180 days? Try this one, okay? Go ahead and push pause, give it a shot. I'll list what your givens and wants are and then tell you to pause again, but a clock gains that much per minute. That's a conversion factor. They're telling you that it's 0.25 seconds for every 1 minute. Now those seconds are actually gained by the clock. So I might write seconds gained so that I don't get confused that there's only 0.25 seconds in a minute. That's silly. Says how many seconds will it gain in 180 days? So my given here is 180 days and that conversion factor that they've given me. What I want is the number of seconds. So I want to change that to the seconds. And what I want to change to is the seconds that are actually gained. So maybe you can kind of see already what to do, but hit pause, go ahead and give it a shot, and then I'll show you the work. Okay, so I would start with 180 days. Hopefully you did the same. I would draw my line, and I can use the days time unit to go to minutes, the same way I did before. So I've got, I can change days I know to hours. I can change hours I know to minutes. And then I should be able to change my minutes to the seconds that are actually gained by the clock. So 1 day is 24 hours. 1 hour is, of course, 60 minutes. And a minute is 60 seconds. Oh, 60 seconds, listen to me. Ha, 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 ha. No, is 0.25 seconds gained. Oh, there we go. 0.25 seconds gained. Oops, there's my answer here, so I don't have to use the calculator. You should have gotten an answer that was 6.5 times 10 to the 4th seconds gained. Now, the reason I use 6.5 instead of like 6.48 or some other long, more sig figs, there's two things here that are estimations. The 180 days, and there's no decimal there, so the 1 and the 8 are the only ones that are significant, so 2 sig figs. And also the 0.25 seconds gained is probably an estimation as well, both of which are 2 sig figs, so this is the right answer. There we go, they're super pretty. So a lot of times, and they do this more so in on level than we'll do with you guys, but you may see something like this on your exam or in a quiz, but we may make up units, ones that you don't know. And that's not weird. Actually, it's weird, but it's not uncommon. So here, a fictitious unit of length called the zither is defined by the relationship that 7.50 centimeters equals 1.00 zithers. How many zithers are in 100 meter distance, 100.0 meter distance? Listed my given and my want. My given here is going to be the 100.0 meter distance. And that's what I'm going to start with because I'm trying to convert out of that. What I want to end up with is zithers as my, my unit of measure. Something else that they're giving me is a conversion factor. They're telling me that 7.50 centimeters is in fact 1.00 zithers, and I'll abbreviate them zith. So what I'm going to probably need to do if I want to end up with zithers is have that conversion factor flipped. I'm going to want to use it at the very end to change from centimeters to zithers. So what I got to do is change my meters to centimeters and then centimeters to zithers. So starting 100.0 meters, I think I can change meters to centimeters since I memorized my unit conversions for those. And I'm given a conversion factor to change from centimeters to zithers. All I had to do was, you know what? I'll just go ahead and write the whole thing out. Was given to us in the problem. So it is 1.00 zithers is 7.50 centimeters. 1 meter is 100 centimeters. The answer here ends up being 1,333 zithers is what you get in your calculator. Now, That's 4 significant figures. If I look at what I've got here, the centimeter Zither conversion factor's got 3 sig figs in each one. And those are estimations, I think. So the 100.0 meter has 4, but I'm going to need to have the fewest total, as this is multiplication and division. So the best answer really would be 1,330 Zither. So I would need a little bit of an estimation there at the end and a rounding to proper sig figs. Now, would you get credit for 1333? From this point forward, you actually do. You get a buffer of a single significant figure off in any quiz or test stuff that we're grading. In advanced chem, in AP Chem, they have to have them exactly right. But you guys get the benefit of having one. So you could have either 1300, 1333, or 1330, and you would still get full credit for this problem here. You're welcome. Okay. There's the Zither. So let's go do one with density. In other words, we're just throwing in a conversion factor here. My given and my one, if I list them, says what is the mass? So what I'm looking for is mass of a 35 milliliter sample. I'm gonna go ahead and write my one. What I want is mass. And mass, you guys should know, the units are grams. So what I'm looking for here are grams. A 35 milliliter sample of concentrated sulfuric acid whose density is 1.84 grams divided by milliliters. So what I'm given here is my 35 milliliter volume at the beginning, and that's what I'm going to start with. But I'm also given a conversion factor of 1.84 grams and 1 milliliter. So that grams divided by milliliter is literally 1.84 grams divided by 1 milliliter. Just like if you were driving 60 kilometers in 1 hour, it would be 60 kilometers on top, 1 hour on the bottom. 60 kilometers per hour is per 1 hour. All right, so I'm going to start with my 35.0 milliliters, and I'm going to draw my line and draw my other line. What I want to end up with is mass. This is a really easy problem. All I'm doing is changing from milliliters to mass, which is grams. I can use my 1.84 and my 1 for my conversion factor, and I didn't need all this extra lineage. Look at that nonsense. We can make it shorter. Okay. So you would just multiply across the top and divide the bottom. Oftentimes density is in the middle of a much longer problem. But just to show you how you can use density or something that has 2 units in it to do a conversion, this is pretty good. So what I end up with here is 64.4 grams as my mass of the sulfuric acid. So just one more. We'll just do one more together today, and then you guys can start practicing these on your own. Here, excuse me, the density of dry air is measured at 25 degrees C is 1.19 times 10 to the negative 3 grams per centimeter cubed. What is the volume of 50 grams of air? So what they've given me here, what they want me to find is volume of air. And what they've given me is a density in grams per centimeter cubed. I want volume. The unit that's volume that I'm given is centimeters cubed. So what I'm going to do is just use the density to change it to centimeters cubed. And the given I'm given, what I am given is 50 grams of the air. So why don't you guys just do this one real fast? It's just like the other one, using density to change to volume, and then come back and you can see my work. Pause. Okay, so I'm just going to start with my 50 grams. I need to change from mass to volume. So the 1.19 times 10 to the negative 3 grams is going to go on the bottom. And my 1 centimeter cubed would actually go on top. And that would be the end of the problem. That's pretty much it. So what you end up here with is 4.20 times 10 to the 4th centimeters cubed as your volume for this. Yeah. So that's what dimensional analysis is being able to change from one unit to another using this, bars and sticks and stuff strategy. You may want to do something different. Please don't. We're not going to convert stuff all year long. We're going to start doing actual chemistry, but I have to teach you the process of doing this before we get there. So all this unit and this unit is very short, is just about doing this process. Okie dokie. Yeah, the next one's lesson 2. So I'll see you guys in lesson 2. That concludes the first part of dimensional analysis. Hope I see you guys soon.